I'm looking
And we
at
are
the...
live,
Are we?
apparently.
We are live. Boom.
Awesome.
Tweet sent out.
Let's give it one more second. I will wait for 10 seconds. There we go. Awesome. So, welcome everybody to another episode of DevBeardOps. Please don't believe the sign that you see up here that says "been streaming." We just had a production failure where we realized that we didn't update our banner since we've renamed the show. So, for those of you that are new, this is where Darko and myself talk about various tech and AWS related topics. And for today, we are going to be talking about deployment day horror stories that we've had. So things went wrong, and more importantly, what we want to talk about is the things that we learned from that. Because over the years, obviously, we've had quite a bit of fun. So, Darko, why don't you introduce yourself quickly to the folks watching us?
Hello, everybody, and welcome back. My name is Darko Mesaros. I am a developer advocate at AWS. My job is to educate, entertain, and scream at the camera at the same time. Well, at least in these circumstances. So hopefully when things go better, I get to scream at you from the top of the stage. But yeah, I'm based in Berlin, Germany. I am originally from Serbia. And yeah, I get to spend my Wednesday afternoons with this gentleman live on stream. So good morning, Tiger Panda.
Ooh, cool. And my name is Cobus. Like Darko, I'm also a developer advocate with AWS. I'm, however, based down in Cape Town in South Africa, so still nice summer weather over here. And I used to be like Darko, where I was a regional developer advocate and also doing a lot of like in-person events. Then COVID hit, and then I switched teams. So I'm actually now part of the online developer relations team at AWS. So even when we go back to normal in-person events, I will mostly be online.
Yeah. Very good.
Hey, Chris.
We have Chris here. Oh, Chris is part of the team as well. Hello,
yes,
Chris.
She's Darko's manager, so
manager.
Darko, you better be on best behavior.
Should this be tension right now?
Dun, dun, dun.
Yeah. So welcome to another Wednesday. Cobus, what are we going to be doing today? What's the plan?
So we had a discussion. What we thought would be really fun is to talk about all of the ways and all of the things that we've been involved in that went wrong and sideways, and what we learned from them. So what we're going to be doing is we're each going to be taking turns to telling you a story about things that went wrong and why it went wrong, and then ultimately what we learned from it. But what we want today is for you to also tell us about things that you've seen and that have happened when you've done production deploys or some kind of release on the day, and then realize like, oh, crap, something just broke. So with that, who's going to go first, Darko?
You do it. I'm going to let you do it. I'm going to say hi to Dennis and Krille here in the chats. Hello, welcome to the stream.
Cool.
Pleasant having you here. So, the goal of this entire thing is to also entertain you with the way we fail, but we're going to try to actually see what is this thing we did wrong, right? So, so we will try to kind of dig up on what could have been we actually done not that to happen. So, Cobus, kick us off.
Cool. So my first one that I want to share, and obviously most of the stories will be from yonder years. I'm not going to be too specific because obviously we don't want to indicate, where it went wrong. But the first one that I want to talk about today was a migration. So back in the day, I worked on a system, and during our deployments, what we did is we had SQL scripts. As part of the code deployment. So it was actually a very nice setup. So the SQL scripts had a format where you had like year, month, day, underscore, and then the type. If it was a 1, it was an indication of a schema change. 2 was just a stored proc change. 3 was there was a data migration of some kind. So because of that, what you knew is that you knew exactly the oh, and apologies for my voice. I've got some kind of upper respiratory infection. So I've taken some things for it, but yeah. Any case, so the whole point
Cobus has a late night voice now, so
yes, I can talk to you in a really deep, sultry voice.
Go ahead. Migrations.
Cool. Any case, migration. So what it resulted in is that because we had these scripts, and also then after the type indicator, there was also a sequence indicator. So we could control exactly the order in which the scripts ran, and we had this bundled up in our release thing. So during one of these, which we'd had done like literally hundreds of before, it got stuck on one of the scripts. And normally our deployments were fairly quick because we tested them beforehand on our staging environment and we ran things there. And then all of a sudden what happened is that the script started running and it ran and ran, as in after like 2-3 minutes, we started panicking a little bit. So logging into the production server, started looking at, and we just see the SQL Server maxing out. It was a Microsoft SQL Server at that time. Not that it's important with this. It's just the specific tooling we used. So we started digging into it, and it ended up being that the table was updating. The change it was making was adding a column with with values in them. So firstly, add the column, not null, as that's not a problem, just adds the column. Then what happened is it inserted a whole bunch of data. And the assumption had been that because we were changing the index, which was part of the one script, and then started hammering it with inserts and updates to the table, what effectively happened is that it started locking up because we had changed. Because when you apply it, it was a primary key change, not just a index change. And what happens is with SQL Server, the primary key is what is used to determine the natural sort order on the actual disk. So if you change it, it means that it tries to reorganize all of the data on the disk. So what was happening is the engine in the background was busy taking all of these rows, moving them around, and at the same time, we were coming in doing a massive update on it, and these things then clashed. And then it started locking down. And now the obvious question is, why didn't this come up in staging? Simple answer is that in staging, we didn't have a data set the size of production.
Oh, I get it. Okay.
Yeah. So it was literally a case of, and because the way we timed it was for an online game system where there was a short gap where we could do things and then go out again. Normally our deployments were under 30 seconds. This summer was like, we can't bring the system back up again because guess what? The migration hasn't finished. So we ended up sitting there for, I think, 30 minutes and dealing with that because there's literally nothing you can do. Because the problem is you cancel the SQL script in the middle that has to start doing the transaction rollback. Because also, this is where I learned a couple of lessons, which we'll get into now, which was then to start rolling back, which means that it takes even the same amount of time, roughly, or more, to get back to the previous state that it was in.
Exactly. Yeah.
So we ran through. So the things I learned that day, and this is one of those fun SQL stories, is that there's a thing called natural table sort order, which is important. So if you've never read up on that, go read up on how is your data actually stored on disk. And if you change it, what are the actual effects? Then what I figured out is that firstly, test with proper production size data because, one of those like staging is not production.
Yeah,
it's a very hopefully a very well-known thing this time. And then the other thing that I learned was that you have to care about batching and how you approach that. So what I learned, there's a whole interesting thing like the difference between a temp table that writes to disks, a temp table that you can define that actually is in the memory, and how to batch things up by taking the IDs and then creating a temp table with the IDs and then taking top 10 based on certain sort orders out of that, joining it, doing the updates, but in small batches, and every time committing that batch. Because the reason, as soon as you commit it, it obviously, during the transaction, because let's say you open up a query and you've got an update, and you just run that one update. That is a single transaction, so try to accomplish the entire thing in one go, and then once it's done, it then commits and says, okay, cool, the transaction is done. So that if something goes wrong during that, it then goes back and says, okay, let's roll back because I know what the starting point of the was, and that then locks up the database actually. So it was a very fun, lots of new things about databases to learn.
And how long did this last? This entire endeavor?
So this endeavor lasted 30 minutes. The issue on the day, because we literally just sat there, wait for it. As soon as it was done, we were like, okay, cool, boom, spin up the system again. Let's just get everything running. And then afterwards, did a deep dive into, okay, what the hell went on here?
Okay.
And then obviously some more experienced SQL people went like, oh, yeah, this is the issue.
Okay. Well, that's a good point. You actually had the chance to speak to some experienced people out there, right? So some people who had the things. It's usually a problem when you don't have to. You have to figure it out, and you keep on relying on Google and copying, pasting things from Stack Overflow, which can be a lifesaver, but also can cause issues. Wow, Cobus. Well, so this brings us to a problem, and this is a problem I get asked quite a bunch. Like when we talk about testing and doing staging. It's expensive to have a production size data set in staging, right? You might think of it as like, oh, wow, I have a database that's sitting out there with so much data on it, and it costs me hundreds of bucks a month just so I can test my code from time to time. So, how would you approach that? I'm wondering. I'm wondering what's your opinion. I have a very strong opinion on that one, but I want to hear yours in this case because ultimately
Oh,
having a staging data set would solve this problem, right? You actually
yeah.
not solve. You would detect this problem before it would happen.
Well, this specific one, yes. But
Yeah.
also just remember your staging environment doesn't have the same traffic as your production environment. So there's that little
Okay.
caveat because we've done on the real-time updates as well. Well, so that the first prize here is if you can have a full copy of the production database somewhere that you can use.
Okay.
Now, obviously, modern times we live in a world where privacy is super important. So you don't want to just copy a production database as is because
Yes.
it's not A, it's not legal, and two is you shouldn't be running things against like private customer data, make that copy available because that's liability and you can get
Yeah.
in trouble for it. Yeah, exactly. Sorry, as M. Schuster measured over here, which is GDPR, a whole bunch of other laws around this.
Yeah.
So terrible idea. So you can invest the time in actually building a masking service, and actually quite a lot of packages. I remember at one point I was dealing with a Ruby system, and there were actually some I can't remember what the gem was, but it allowed you to say, "Listen, take this and mask it," or this is the schema, generate some random data. And the problem, unfortunately, is SQL databases or relational databases link all the data together, and it kind of needs to
Yeah.
make sense. Otherwise, it doesn't just help you've got the volume of data if it doesn't make sense. So that's the problem. So ultimately, what it boils down to is that um, I would love to test that production. It's not always feasible, but I think what would have helped in this case is like um, going through all the scripts in more detail than normal. And at least doing some kind of like before you run the script is like ask it to generate you an execution plan because most of the database engines could do that. And you say, here's the script, go figure out what the execution plan is going to look like. And what you should be able to determine from that is like, oh, okay, there's going to be like table scans or this operation that's going to be heavy.
Yeah, that's a fair point, right? So there's multiple things here that we need to think about when it comes to properly replicating a staging environment, right? So from doing proper sizing to proper traffic, even, right? But when it comes to data, if you talk about masking services, wouldn't it be easier? No, this is me just spitballing. Would it be easier to just create like how's it called a dummy data set, right? Create a data set that is the exact same size and format with just random information, well, actually semi-random information. Would that make more sense?
Up to a point, but not always. Because remember, what if you think about, let's just say, people names. If you're randomizing, that might be uniformly distributed, whereas in the real world, it's definitely
It's
not.
not, yeah. Okay.
Also, values like let's say you've got a running transaction log with numbers. Those numbers need to make sense in terms of the
Yes.
incrementing and decrementing the account and all that. So you could potentially build a system that, let's say, parses the real-time data and then just masks it on the way out, or do some pop it on another queue. Let's say you've got what I've actually seen someone do is they used Kafka,
Kafka.
and then what they would do is they would have a secondary system that actually reads the same stream with its own pointers, and then actually build. But in that set of code, it had the whole let's mask the sensitive data, and then write it. So it was dummy data, but you couldn't correlate.
That's a very interesting point. Yeah. See, I haven't thought of this. Like this really hasn't come to my mind of thinking about. Oh, the numbers need to make sense when they absolutely have to do, right? If your business logic relies on it. So yeah. And MSLStar says here very tricky, especially when you have a lot of business logic that cannot be easily replicated using mock data services. That's the whole point. Yeah. So.
Yeah.
So cool, yeah. So you have to be careful about your data set. Now you can do some obfuscation because ultimately numbers should not matter unless they're personal PII, right? That's
Personally
where,
identifiable information.
yeah, personally identifiable information. As long as that can be obfuscated and put something else, I guess that's gonna help. You will never have 100%. Equal data set, so you will not have an exact copy of production, and you shouldn't. I mean, ultimately, let's be honest, your code, your data migrations, or everything you do, all of your operations should be able to handle different things to an extent, right? So if you okay, yeah, but if you should, I put the should here, right? If you handle data So if you haven't handle migration operations with an expected set of data, that can be slightly problematic.
I can one up you from that.
Okay.
I also worked on a system a few years later, which was very complex. It involved Microsoft SQL again, and then there
Okay.
was a originating data server. Then
Okay.
there was replication set up to a second layer, and in that layer there was some logic running involving triggers and some other things to actually take the data and spread it across multiple different
Okay.
data sets to because it was a multi-tenant system. Then I got the data in the middle, split it into single tenant databases. Then those databases were then replicated into the actual tenants' back office systems because they were completely isolated.
Okay. Well,
And what happened there is if you change the shape of the data at the top, you need to change it everywhere, and then also handle the migration and all of that.
Yeah. Well, okay, yeah, fair point, fair point. I mean, ultimately, there are some data constraints that you have to be careful of. Like, for example, if you have a specific number of users from location X, you may want that data to exist on location on that location, right? And if you have mock data, you want to be able to have that location or that constraint there as well. But I think by just stripping PIIs or personal identifiable information from the data, you should be fine, at least from the GDPR perspective. But going beyond that, when it comes to cost, right? So, it's expensive. It's having terabyte of data, that's expensive. I would argue that failing is more expensive with a badly executed migration due to the fact that you couldn't test it. So, but I'm sure somebody will say, "Hey, oh well, that's not correct. We can just lose a 1 hour of work if we fail."
Yeah, no. Bless you. No, yes, no, wait. Oh, there we go.
Yes. In Serbian, we
Respiratory
say when
system
somebody
failure.
in Serbian when somebody sneezes after saying something, we say, "Oh, it's the truth." So, there you go.
Oh,
Correct.
yeah.
Well, that's cool. That's cool. So how would you approach it today? How would you handle that exact same situation today, now
Well,
that you're this much smarter?
well, this is much smarter. Back in those days, I still had hair. Yes, this is a scary thought. Back in the day, I had no beard, glasses, and hair. Um,
Wow.
so
Wow.
you would not recognize me. Well, basically, having gone through that, I spent a significant amount of time digging into how the actual database engine works. So, like I said, I learned about the table sort orders. I learned about exactly what does the engine do when you add columns, remove columns, try and change column sizes. So obviously increasing the column size. So let's say you've got a variable character column, if you make it wider, that's a relatively easy operation in the sense that you don't have to worry about data truncation. But if you're going to a smaller data size, then you do have to worry about it and how do you handle those kind of things. And also allocation on the disk, because that's normally the thing that bites you. So SQL Server at that point in time worked with if the table started getting full, because it pre-allocates disk space, and this is now still in the day of pre-SSDs. So allocating disk space was actually an expensive operation. It would take the table size, increase it by 10% immediately to grow it. And the problem is if you're filling up the table rapidly, you get multiple of those queued up as well. And that also slowed it down. So it's like basically spending time to understand what does a database server do when you give it commands. So that was the ultimate lesson. And then once I had that in mind, then it's like, okay, now when I think about changing schema, these are things I have to worry about because I know what the engine is going to do.
That's a very good point. Understanding the impact of the change is key, and we tend to think like, oh, it's just going to change the schema, or it's just going to change the index, or it's just going to do something very abstract in our heads, but ultimately it might do a lot more in the back end as well. So
oh yeah.
Okay, there's a comment here by Miss Suster regarding the thing about expenses, right? About being expensive. So Miss Suster says, let me actually put this on the screen. Expense was our problem in my last company. We tried to spin GCP environments, including DBs for each team using Kubernetes namespaces, allocating a theme-dedicated cluster and databases, but it was too much overhead for DevOps and expensive to maintain. Absolutely. So I get that, and adding this level of customizability, or giving each team the ability to spin up their own clusters and whatnot, increases cost. That's just a fact. It's unavoidable. It's there's no way to have it free. But let me try to stand on my high horse here and say that ultimately the price you're paying for not having this is your developers are less likely to experiment. They're less likely to try bold new things to improve your product. So if you, and we're all motivated by fear, right? Everything you do in life is kind of because of some sort of fear. And if you fear that if you push this button, you will break production because you couldn't probably test things in a proper environment, you will most likely not do it because, you know what, I'll just be safe and I'll just make the small change. That's all good. So you lose some of that value of people experimenting, trying new things from removing that. So it's very hard to quantify, and people, I've had this discussion yesterday with somebody. They told me, help me quantify that developer experimentation. Put a number on it. I can't. I don't know. I like 7. Right? I really don't know how to put a number on that. But it is pretty cool. It is pretty important, I would say.
One way to think about it, which is often interesting, is developers are expensive. If you think about what salaries are like at the moment, if you compound having a team with 5 of these developers waste 5 hours a week, that is actually a insignificant number. It's people will notice that number if you start talking to them that way. And the way you phrase it is you just lost a few $1,000s worth of developer time. Are you happy with that? Versus saying, let's just spend $1,000 to get this environment up and running.
Yep.
But especially with Kubernetes and the whole rise of microservices, what tends to happen is that when you have the monolith, being able to spin it up locally with a local database was fairly simple. Dev machines tend to be powerful enough to handle that.
Yep.
Then we went the microservice route. Now it's all of a sudden, okay, cool, how do we run locally? Well, you can use, micro Kubernetes. I always forget what that one, Cube. Okay. There we go. To run it locally and simulate all of that. The problem is that works up to a certain point until you've got too many microservices to be able to spin up locally because you don't have enough resources anymore. Then it's okay, cool, let's just take it to the cloud, spin it up there and run it. And you end up in the point where you're still trying to use the same old way of testing things, full end-to-end testing the way you used to with a monolith. And that doesn't work as well with distributed microservices. So that's where you've seen the rise of, for example, launching things as with feature flags. And then toggling them and being able to release in production, make sure that the code part isn't hit, and then only do it. So,
yeah, and there's a comment here by msusser microx.io as well, and Pinecone here mentioned something for you, Cobus. DACPack generate D as a dev tool. I have not used that. What is that?
It's the ability to run Kubernetes locally. So it's basically an interface, so you can use your YAML files and use your local Docker installation and run a local version of Kubernetes effectively.
No, not that. There's a comment here by.
Oh, sorry, DACPack. Sorry, my brain. DACPack. That's where you can bundle a bunch of upgrade scripts, and it gives you a lot of information about that as a single unit, a deployment unit, if I remember correctly.
Oh, okay.
Now, this is many years ago, more than a decade ago that I used that last. So it's a little bit fuzzy.
Yeah. Yeah, and Pinecone says 42 is the universal answer to everything. Absolutely, I agree. But it is very important. If you go ahead to your C-level executives or your management and tell them, well, to quantify this, it's 42, you're going to get a weird look. So it's sometimes...
Or a very good look if they're a fan.
Or an amazing look if they're a fan, yeah. So it is very important to kind of try to quantify those things, but still to this day, I don't know how. I don't really know how to put this thing in a data-driven sense. I cannot say, unless I have information, unless I say that, with this set of tools, so this requires you to test it out. So with your staging environments, proper production compliant staging environments, your developers will commit code to production X times a week, compared to having no replicated production environment in such a state. How many times will your developers commit code that is, bigger than X amount of line changes? It's very arbitrary. Again, it's not super data driven, but this is the way to approach it. One of the things. Okay,
yeah,
that's very good.
Yeah.
it's weird. Like for me, the most difficult thing when it comes to migration is the data migration, actually working with your databases, because everything else is more or less. Oh, it's a stateless system. I don't care. I'll change my code. If it breaks, I'll roll it back.
Yep.
Oh, when you make a change on a database at scale, when you see that big old number, 5,830,002 rows affected, that's a problem. So yeah, it is. Ken, we are the same species. We were told we look alike. I can see it. I'm not sure what you're talking about, but yeah.
I was telling Darko earlier. Let me get the title quickly of the person. I had someone on LinkedIn reach out, and their title ends with "and digital twin researcher" at a university. So I'm
researcher. Wow.
So I'm very, very keen to see what comes up there. So yeah.
Yeah. Select first before delete. A lesson for everybody learns exactly once.
Oh,
that's a great one.
Ian.
From
No.
Ian.
So see, Ian. Also, day 2 of my very first job, literally day 2. So up until this point, just quickly to set the scene, I had learned SQL and I knew about SQL with a pen and paper. I had not yet run any SQL on a machine. So day 1, I ran some SQL. Day 2, I wrote this awesome update script to pick up people abusing the system and just flip the isBan to 1 on their user's account. Okay. So I had this big thing. So first I did it as a select, checked that it did exactly what it was, went through the data, spent a whole day going and checking with the senior dev, and everybody's like, cool, this is awesome. So then I turned it into an update statement, and then I ran it. And firstly, it ran really quickly, like in done. Okay. And I'm like, that's odd. The select was actually quite slow. So because I'm doing string compares and like this much wear. And then, if you highlight update table, set value, and just those 4 lines and not the where clause, and you click run, it only runs those 4 lines. So it locked out everybody out of the system. So yeah.
Oh boy.
Yeah. So yes.
How is it called? How is that called? It's the oh no moment. It's basically the time it takes you from hitting the enter key for that thing reaching your brain.
No. It wasn't the enter key. It was the moment of looking down, like number of rows affected was about 500 something thousand, and we had 500 something thousand users in the system. And like you just sit there going like.
Yeah, it's weird how we judge like the success of a certain thing we do by the length of time it takes, right? So if something is done really fast, immediately you're like, this is not good.
Yeah. Especially if it's complex SQL queries.
Yeah, it's like, okay, so what did I do? And you get this thing where your back just kind of starts to go up, and you're like, you don't know what's happening. But okay, that's very interesting.
Oh yeah.
Well, I mean, ultimately, in your case, Cobus, I mean, my thought is like having a proper staging environment set up that will replicate your things. And thank you, there exists a thing called infrastructure as code now, so it's relatively easy to do those things. So it is very, very, very okay. It's much more simpler to replicate production into staging than before, but there's a couple of caveats: storage, traffic, and of course the cost at the end of the day. So yeah.
And I mean, this kind of
here. This kind
of thing, like where
2004 worked a 36-hour blitz to hit a deadline. Missed a where ID equals var, an input from web form. I overwrote all 360,000 rows in the system with the same row. Luckily, I had a backup right before the release. Oh boy, you were lucky, buddy. But here's the thing. How would you test this? Like, how would you... Like, this is a human error, right? This is where no matter what you do, what kind of a staging system you have, it's a human error. So you need to find a way to prevent such a thing happening, right?
Well, the thing is, what you could do here is that because this updates an actual row in the table, I'm assuming this was in code, given that we see where ID equals var from web form somewhere. So there's some code between the SQL and the actual code, is that you can build a integration test where it actually has a sample database, runs that, and then validates the data. The problem there is that I can easily see that your validation test would use the ID from the web form to test it, so you might still have missed it, because guess what? Yes, that row is going to be there and it's going to be up to date, but it's going to be many of those. So the bottom line here is that don't work through the night because for
Don't work
those
through
of
the
you
night.
that aren't aware, so here's a fun thing. Pitching up drunk in the morning at work. I don't think anybody would do that. That's like a very simple, we know that's a terrible idea, you're going to make mistakes. However,
Although,
working late or through the night, that's perfectly acceptable, except they've done studies where they show that sleep deprivation is the equivalent of being drunk
yeah,
in terms of cognitive function. So guess
yep,
what? You're drunk on the job. You shouldn't be
yep.
touching the keyboard. Go home, sleep.
Correct. It's very important not to do that. Like, I'll give a short example of me doing something similar. I was actually drunk at this time. I was on call for New Year's Eve in a company I used to work for, and they called me like after midnight on a New Year's Eve. I was out drinking, and they're like, "Oh, our email system is down. You have to come back and fix it because it is, we need to have it tomorrow in the morning because we need to do inventory or whatever," right? Okay, and I was like, "Whoo, this is gonna be fun." I get back home, and it wasn't a big deal. The Exchange data stores were just disconnected due to some network outage or storage outage, whatever. But it takes like 20 minutes for you to reconnect the data stores for Exchange. It took me like 4 hours to do that because I had trouble seeing the screen, and I was like, "Okay, you're dealing with email here. Everybody's email in the company. Be super careful." So I was especially careful not to do things, but it took me so long, and I could have broken all the things. Moral of the story: don't work drunk, absolutely, but don't even work after 36 hours if you can prevent it. But one thing about in this exact comment by L Switchblade, the script that has ID equals var or whatever. One of the best things, people who make tools, no matter what kind of a tool you do, the best thing you can do, if possible, is create a mock execution. Right? Have a dry run flag on your tool. Have something to execute it, but not actually do things. It actually will increase the confidence of the person running the tool a bit more because, hey, if I do the dry run, I will actually see, does my tool do what I want it to do to an extent, right? You will not see it completely, but it keeps up this wonderful just confidence that it will actually affect this many thousands of rows. It will do these commands or a lot, and you see a lot of things like I think PowerShell has it like built in on a lot of its command. There's a dry run or is it a dry run or a no run? They have this flag to do it. Yeah, I love that, and there are also this. There are some tools which I've worked with which are by default a dry run. Unless you set a flag says execute equals true, it will not run. So I love that. And I love that thing when it comes to scripting. The first thing in a script is a false flag. Like there's a flag set to false. Unless you go into the script or change a parameter, change that flag to true, the script will not execute. Love it so much.
Oh yeah, no, that's awesome.
Yeah.
So, Darko, tell us.
Darko. Let me just comment one more thing here. There's a comment here from Glitch DNB. Managing a large shared email platform and getting SMTP IPs listed on a UC protect on the second day is up there. Yeah. So in this case, like you've made a mistake by basically blocking IP addresses on there, and it's a small change I guess you made. It's not a massive thing. It was like an operational thing you've done, and it's very difficult to protect against those, right? It's very difficult to protect against those little things unless you have an audit system that keeps on checking for changes, right? So like if you do all of your changes through infrastructure as code, you can do things like creating these unit tests, or not even unit tests, they're called well, they're unit tests basically. They're checking for outcomes or checking things if they should be in that way. Like you can use even inspec for these things, checking if a specific configuration is set the way you want it to instead of this. But again, this could have been anything in your use case. But okay. Then let me tell you my story. Then I have a story also coming from a few years ago. It was before I joined AWS. Again, a company that shall not be named. And let me actually put you, our audience, in this story. So imagine you being a sysadmin, which I was, right? You're a sysadmin. You come to this company, and the company is a big company earning a lot of money, and the way the corporate infrastructure is set up is questionable, right? The network layout was, how can I say it? They used the /8 in a single subnet. So not optimal, right? You wouldn't have all of your desktop computers, all of the servers in a corporate setting in the same subnet. And I came there together with an older sysadmin, and one of the first things the first thing I done on my first day was like, we have to stop giving static IP addresses to people because that was a thing that happened. Okay, I changed that. The second order of business, let's re-architect the network, because having a single subnet does not work. And you go ahead and you decide, okay, let's see what's the best way to approach it. We have multiple floors in the building. Let's create a VLAN per floor, right? Let's do a VLAN per floor. That would be the best approach. And okay, you brush up your Cisco skills, and you make your scripts to change everything on Cisco, and you make sure that you have all the fiber connections between different switches on different floors just to make it work. Oh, we're going to have separate VLANs for printers. We're going to have separate VLANs for Wi-Fi and separate VLANs for servers and desktops and all of that stuff. You set all of those things up. You spend days writing your Cisco configurations or modifying Cisco configurations on a text file, and it's amazing. Then the day of change comes in. And you decided it's going to be a Friday. Because in this case, a Friday is a good change. I would argue, right? Doing this kind of a big change on a Friday is a good day to do it, because you have the weekend if you screw something up, right? So then you go ahead on a Friday, and just before you do your change, you're like, hey, with your colleague, and let's call the colleague Vlors, yeah. And you decide with your colleague, and let's call your colleague Larry. You and Larry decide, hey, before we do this, let's go grab a drink. A problem starting there, right? So you and Larry go have a drink or two or seven. And you, in your infinite wisdom, you decide, you know what, Larry, I think after 7 drinks, we should not be doing a change today. Smart, excellent. Ooh, that's the first thing you should not do. Cobus told us we should not do things drunk or tired. Excellent. Okay, no change on Friday, but we need to make a change this weekend. Excellent. You know what? Let's just do it on a Sunday. We will take that day. We have the whole day in front of us. We don't have to work nights. We'll just get here in the afternoon and just start working on making all the VLAN changes. It's a sitch. We just need to upload the changes to Cisco's on all the switches and just make sure that all of the DHCPs works and whatnot. Sunday comes. You go to the office. Again, coffees, food, you order pizza, you start doing it. Oh my God, it's working. Oh, you're on your floor, you change the VLAN, it just works. Oh, DHCP there and there. Oh, excellent. It
the dev lifestyle.
Works. Yes, it's like you feel elated. Oh my God, this works everything. All of a sudden, things just start working. Certain floors just don't get IP addresses, right? The printers don't get IP addresses. The Wi-Fi doesn't get IP addresses. Problem with when Wi-Fi is if you have no Wi-Fi, the laptop you use to debug things doesn't get connected. So you need to find a wall port and plug in your laptop to the Ethernet. But there's no DHCP there as well. Okay. Then you keep on running between floors, and the floors are kind of separate from each other. So you can go down to the place where you have the servers. You can plug in there just to make sure if it works. You end up connecting to like your phone and then using the VPN via 4G to connect to your company from outside. And it doesn't work. You keep banging your head. Why it doesn't work? Why? And things happen is that all of a sudden it's 3 a.m. And the problem that it's 3 a.m. and that you are not like 1/4 through is that tomorrow is a Monday. And the Monday means people need to get into work in the morning. And you're at this cross point where Larry and yourself are like, okay, if we stop now, we can roll back. But if we do not stop now, we have to go through with this. We have to fix it. This is the point of no return. And it's like, okay, what do we do? What do we do? And like, both Larry and you are lying on the floor, trying to see what would be the best thing. And L Switchblade says here, fail forward, take the risk. Exactly what we did. And we spent the next 3 hours, it was 6 a.m., and it was really close to like, this is it, we failed, we're going to get fired tomorrow. The company will not be able to operate with this, right? We're going to have to send everybody home to work from home. No printers, no Wi-Fi, nothing. Oh boy. And I was already thinking, okay, how can we set up 4G modems across the company so people can connect to Wi-Fi at least or something. It turns out, in your infinite wisdom of configuring your Cisco switches, there's a thing you forgot, and it's a thing that's important, but kind of doesn't seem important initially because a switch will work without that. VLANs will work without that, perfectly fine. There's a thing on Cisco or in switching. It's called a DHCP helper. It's basically telling this VLAN, what is my DHCP server and who should I ask for my DHCP? Because when a DHCP request comes out, it comes to the VLAN. It goes, hello, who is the DHCP server here? And if there's no helper coming from the switch, there is no DHCP server in that VLAN. So it turns out that adding that little thing, plus one more thing failed. I had a broken SFTP thing, the fiber channel plug you put into a switch. That was one of them was broken, but that's a minor thing. So this thing, and as soon as I added those things to a VLAN, all of a sudden, everything works. And it was literally like 7 minutes until 7, right? It was just here before people started getting to work. People got to work. Everything was working. I lost like all of my hair, I guess, back then. I don't know. I'm sorry, you lost all of your hair, and and it was just such it was a success at the end. It was an utter failure in a sense that you wasted a day and so much nerves and so much things you've done. It was just excruciatingly bad, but you did make it, right? So that was one of my worst failures in my IT careers, where I really spent a lot of my brain power and a lot of my nerves trying to think, shall I go with this or do I fail? So it was fun.
Yeah, no, it's a hard one.
Yeah, not really sure how would I fix it. Not really sure how would I I would not do this again. I'll tell you.
Well,
I'll be. Go ahead.
Remember, that's where experience comes from. Someone who's experienced is not someone who knows everything. It knows it's someone who knows all the ways to break something, so they know not to do that.
Correct. That's a very good point. Like in my case, I'll be honest. I never tested this change. I haven't. I was like, oh yeah, fuck, it works. It's a Cisco configuration file. It's all in a text. I can see it working there. I even had a Cisco switch behind me so I can test it out, and it worked. So it worked. I changed the VLAN and it worked. Why did it work? Because I set a fixed IP address on my device, and it was fine. So I didn't take in all the variables of a problem. And yeah, that cost me a Sunday. So I think couple of points I've learned from this entire endeavor was. There are days where you can test on a Friday, and it makes a lot of sense because, hey, if I did it on a Friday, I could have failed and just come next morning and just work with it and trying to figure it out. And I would most likely figure it out. Larry and myself would probably figure it out. Second thing, when doing such a big change, and when I say a big change, I mean this is a show-stopping change. It stops the company if it doesn't work. Do everything you can to test it. Like I didn't do everything I can to test it, but there is something that there is something that I could have potentially maybe try to replicate it in a small office or in one floor at least where it's not so important or something like that. So there are things that I would have to be careful of, right? So in this case, but okay.
Yeah, that's. I mean, networking is always, especially if it's like physical cables on things. It's a fun one to do.
Absolutely.
Yeah.
Yeah. No, well, and actually, it's been a very long time since I've done such a change. It's been a very long time since I've done networking changes like that. So, it's I don't want to do it again, to be honest. Like I know what to do right now, but I really do not wish to do it again. Let me put it this way. So,
Mm.
uh, uh,
Yeah.
it's easier with a VPC, I would say.
Yes. Virtual networking definitely easier. Yeah.
Yeah.
Yeah. No. I'm trying to think now. What's the next most fun one that I had? There's a fun one just as a minor story, like where I implemented a multi AWS account Terraform pipeline. It had all the bells and whistles. So Terraform was part of the CI/CD pipeline.
Okay.
What happens is that you push a pull request, it
Okay.
spins up multiple workers, and then it ran them in parallel. So basically, the Terraform plan on all the different environments, took
Okay.
all of the results and put them back in the PR. It showed you what would happen, and then once you actually say execute, it would say, okay, cool, execute on dev, then go to the next one, next one, next one, next one, next one, like that. And I wasn't paying attention. Once again, I think I was overtired or just in a rush or something.
Okay.
And so I look at the PR, eyeball, okay, Terraform output, there's no error, okay, click go. And then it starts running. And it's like on dev, and I'm like, wait, I saw something bugged me over there. And then I went and looked at the output, and there was a nice little, because with certain resources, if you change values, you can't edit them. You have to recreate the resource. In this case, resource was a database.
Oh wow. Oh yeah.
So it's like one of those, like looking at it, you see it running on the dev server, you know you've got about 3-4 minutes per server before it goes on to the next phase. It's like,
Yeah.
right, cancel job, cancel job, cancel job. So luckily I only broke the database for the dev server, and we could just rebuild it from sample data, luckily. But yeah, that was almost a not so fun experience, because once again, not paying attention.
Not paying attention, and no matter how much you do things, how much you're being careful, as a human being, you will make a mistake, right? So and don't beat yourself about it. Like I'm telling this to everybody listening here, do not beat yourself up because you made a mistake. You will make a mistake. That's what we do. Humans are not great at following instructions. That's why we are not computers. So I think by trying to remove the sources of failure, removing the potential points where you can actually make a mistake, and introducing as many checks as you can is very important, right? So now some ways you have to be really creative to test if that works or not, right? Some things like your infrastructure as code, you can just have a simple unit test to do that, right, before you even make a change. But for some things, you have to really just test before you actually replicate. So it's kind of a very important thing. There you go. Ian says it.
Nice. Yeah, Ian is. I think we need to get Ian on a session here. So I'll talk about Terraform. He can do CloudFormation, and you can talk about CDK, and we can see who wins.
Okay. Ian, we will have to get you here on stream to make a discussion about these things, to see who can talk, who can be a bigger fanboy.
Yeah. No,
Ian is actually Ian is a creator of a few lovely tools for CloudFormation and a bunch of things for AWS. So a big fan of that. So Ian does great things with CloudFormation. Yeah, and me as a
channel points on CDK to win.
Cobus, I don't see anybody saying Terraform here.
Okay, cool. Let's quickly check. Terraform people, CDK people, and CloudFormation people, please put up your hands. And also, I don't use tools. I click in the console people, because there are certain scenarios where that still is a thing. So give us a quick indication who's used what tools, because I'm very, very curious. But
can I also vote?
No.
I just did. I'm sorry.
Oh, CloudFormation. I see.
Yeah.
Another, I think one of the most horrific things I dealt with is, so I just spoke about having a nice RAWS CloudFormation. We have a cowboy in the house.
Ian just does it. Ian actually uses
Yeah.
CloudFormation, creates everything in a custom resource, and just uses the API. So that's
Oh well, that's impressive. No, I think
no
we might have
Terraform
lost
love
Darko.
here.
Let's
No
quickly check.
Terraform love here, Cobus. What is it? What is it? We
Yeah,
usually have a
Darko's
few
just
folks
quickly
using.
reconnecting.
Oh
Or I
wow.
am. Give it a second.
I
Let's see. Darko, are you back?
I am
Yeah.
here. I am here.
Cool.
Hello.
It looks like we're cool. So I just spoke about nice CI/CD pipeline that rolls over your infrastructure. So now, on the other side of the spectrum, an old job as well, where when I got there, because one of the things I was supposed to do is help them with some of the automation and things, is that they were deploying code. And
Okay.
the deployment process was very interesting in the sense. So first off, using SVN, not Git.
Okay.
Secondly, here's the thing. So, as we all know, as software developers, features are distinct single units of things that form this little bag that's the actual thing that you deploy, right? So, what you do is you have the current production branch. And then once you have feature A in a branch, feature B in a branch, feature C in a branch. And then when it comes time to, hey, listen, we're going to deploy, you ask the people, what are we going to deploy today? And they say, well, can we please deploy feature A and feature C?
Okay.
Then the person would go, sure, no problem. Remotes into the server, SVN, check out current production branch. SVN, cherry pick, merge from, so it's not the full branch with feature A. Cherry pick the commits that they knew were the actual code changes for that specific feature from the branch, bring it into this production branch, cherry pick from branch C,
Okay.
merge it all by hand on this machine, compile and push to the actual web server to run it in production.
Wow.
Yeah.
Okay.
There were many times where things went horribly wrong in the sense that, the code obviously didn't operate the way it was supposed to. The database scripts didn't run. It was just like, chaos.
See,
But then
I never
the
used
challenge there,
SVN.
however, wasn't technical. Yeah.
Yeah.
Well, SVN is, but you could still, a similar problem with Git. Even Git might be a little bit better with handling the branches, but still, you've got the same problem. Because guess what? The underlying database also needs to change. You might have forgotten because scripts are run by hand.
Yeah.
So it was interesting. And then the biggest challenge was convincing business that they can't decide on deployment day which features go out, that they had to plan. That was actually the biggest challenge here.
Yeah.
Yeah.
And there's a few things now that can help you with that. Like a change calendars are one thing, right? Just having a proper change calendar when you can do things, when the plan is when the things have to go out. Like on AWS, you even have like the change calendar on Systems Manager. It's not for deployments per se, but you can kind of use it for those things as well. So it gives you the ability to actually block off days for your Friday afternoons to not deploy code. So that is a very good thing. Yeah, well, and I think it's a great segue into something else. So because we're getting closer to the hour, we talked a lot about failures here and release day horror stories and how did we experience things. Next week, here's a suggestion. Cobus and I will talk about failing, but the different costs of failing in different places. Hear me out. It's not the same amount of money or whatever thing you're using as to measure cost to fail on your desktop or in staging, right? So let's talk about how we can mitigate all of these things in different phases of your CI/CD deployment or your deployment pipeline, and where is it the best to fail, and how can we do these things? So fault injection simulator. We have a plan of a chaos engineering stream coming up sometime soon. So be on the lookout for that. We will announce that coming up because we definitely want to play with the FIS. But next week we're going to actually talk about the differences and the way you fail on your workstation, the way you fail on unit tests, the way you fail on your staging, it is staging, but it's called an integration test. Yes, integration test, your penetration test, your load tests, and of course, when you fail in production, how much does it cost? So on the same place at the same time next week. So Wednesday, 1 p.m. Central European time, 2 p.m. South African time.
Yep. We don't have time DSC changeover. Don't worry. Our
You don't have
lives
it.
is-
Okay. I'm not sure when is Europe changing. Are we changing our time zones?
No, Darko, don't go there. I've already figured out that for the next month, there's one changeover on the 14th, there's one on the 28th of March, and then there's another one for April. And I have
Okay.
to deal with people on all three of those and then schedule things. It's
We should just switch to using UTC for everything, or better yet, let's use Unix time. So next week, Cobus and I will discuss these things a bit more about failing within the actual code deployments. How can you actually catch the failures on your text editors, your unit testing, your whatever's, right? So that's fine. Can we have a serious discussion? Yeah, that would be very good. If we can, we can remove time changing. I would love that. But yeah.
Oh yeah. But just before we go, just for those that are watching us, because we are streaming on multiple different platforms, give us a follow on either our Twitch or on our YouTube channels. The reason for that is that we currently are streaming on the AWS channel, but at some time we might be moving the show to different slots, and we may not be able to get a slot on the AWS one, and then you can still listen to us then.
So we're actually streaming on all of these, both of these, well, all three of these YouTubes here, and both of these Twitch channels, as you can see, are Up12 and Cobus Bernard. Just give us a follow there if you, in case we are not on AWS, but we really appreciate you all being here and commenting on this. Hope you enjoyed this. Interesting foray into how we failed at some certain things and some things we learned from it. We fail, so you don't have to, right? Is that the way you do it? Join us next week at the same time. So let's talk about failing your code deployments in a pipeline. Okay.
Oh yeah.
Thank you, Cobus. And thank you everybody for joining. Thank you, Ian, for being up so late. Ian is from Australia, so it's a bit late for him right now. So Ian, you should go to sleep probably. But yeah.
Remember that thing? Don't be drunk at work tomorrow.
Yes, we talked about it, Ian. Don't be drunk at work, or don't be sleepy at work tomorrow. Thank you all, and good night, Ian, and see you all at some other point.